The James Webb Space Telescope is the latest scientific marvel constructed to help us find habitable planets in the universe. Much like its predecessors, the Hubble and Kepler space telescopes, the JWST is expected to enhance our knowledge of how the cosmos came to be and what inhabits it. The telescope is designed not only to study the structure of the universe, but also the countless exoplanets littered across it. In a new report, NASA has announced that the JWST has found evidence of water on a distant planet. So, let's take a closer look. When scientists planned and designed the Hubble Space Telescope, the most groundbreaking astronomical observatory of its era, there were many things about the universe they didn't know. One of these unknowns was that the stars and galaxies existed already a few 100 million years after the Big Bang. But even if they had known about these early stars and galaxies, they didn't have the technology to make Hubble see them. It became obvious that another, even grander space observatory will be needed to get to those early stars and galaxies. Those that had lit up the universe after hundreds of millions of years of darkness that followed the Big Bang, when the expanding space was only filled with hydrogen atoms. The technology that would eventually enable this observatory, now known as the James Webb Space Telescope, to see that mythical first light in the universe had yet to be developed. This missing piece of technology was infrared detectors that would be able to collect the faint light coming from those early stars and galaxies more than 13 billion light years away. Hubble was built to detect visible and ultraviolet light. These early galaxies do emit visible light, but because of their distance, the wavelength of this light gets stretched into the infrared part of the electromagnetic spectrum by the so-called redshift. The technology has come a long way since Hubble's early years, and the James Webb Space Telescope project has been pushing it further along the way. The James Webb Space Telescope's giant mirror will feed the light of stars and galaxies into 4 cutting-edge instruments designed not only to take images, but also to analyze the chemical composition of the near and distant universe. This is done with the technique known as spectroscopy, which looks at how matter in the universe absorbs light. As different chemical elements absorb light at different wavelengths, astronomers will be able to reconstruct what stars, nebulas, galaxies, and planets within James Webb Space Telescope's site are made of. These improvements in the resolution of infrared imaging are critical for imaging the furthest reaches of the universe. Where the Hubble Space Telescope or the recently retired infrared telescope Spitzer could provide only a rough estimate of an ancient galaxy's age and chemical composition, Webb will deliver with precision. The telescope will also allow scientists to study the chemical evolution of the universe. Astronomers know that the early universe had a very different chemical composition from what we see today. It consisted only of hydrogen, helium, and just a little bit of lithium. All of the other chemical elements that we see now, including those that make life possible, were cooked up throughout eons inside those stars. The spectroscopes aboard the James Webb Space Telescope will be able to probe the chemical kitchens of those early galaxies, seeing what was cooking inside individual stars and what they fertilized the wider cosmos with when they exploded in powerful supernovas. While the James Webb Space Telescope and the Hubble Space Telescope are frequently compared, their images will be quite different, revealing different aspects of the universe. While Hubble's strength is imaging the visible universe, Webb's infrared superpowers will enable the telescope to see through dust right into the heart of nebulas, galaxies, and star-forming regions that are hidden from Hubble's view. Previous infrared observatories, such as NASA's Spitzer Space Telescope, were much smaller than Webb. Therefore, they couldn't see as far as Webb, and when they did, they only glimpsed those star-forming regions in a limited resolution. While astronomers have been able to map star formation in our galaxy, the Milky Way, the James Webb Space Telescope will rip open star birth centers in farther away reaches of the universe. Just like with Hubble, science has moved forward since the conception of the James Webb Space Telescope, and new areas have emerged that may not have been foreseen when the first light machine was first conceived. In 1995, the first 2 planets orbiting another star other than our sun were discovered. Since then, thousands of exoplanets of various sizes and kinds have been detected, and while not designed with those potential other Earths in mind, the James Webb Space Telescope turns out to be positioned to not only discover many more, but also to tell us much finer details about their nature than any other mission before. One of JWST's instruments, the near-infrared camera, is fitted with extra implements called coronagraphs, which block out the light of a star to see more clearly what is happening around it. That indeed might involve alien systems of planets, some of which might be habitable, with water and an atmosphere that could support life just like Earth. The ingredients for life are spread throughout the universe. While Earth is the only known place in the universe with life, Detecting life beyond Earth is a major goal of modern astronomy and planetary science. Thanks in large part to next-generation telescopes like the James Webb Space Telescope, researchers will soon be able to measure the chemical makeup of atmospheres of planets around other suns. The hope is that one or more of these planets will have a chemical signature of life. Life might exist in the solar system where there is liquid water, like the subsurface aquifers on Mars or in the oceans of Jupiter's moon Europa. However, searching for life in these places is incredibly difficult, as they are hard to reach, and detecting life would require sending a probe to return physical samples. Many astronomers believe there's a good chance that life exists on planets orbiting other stars, and that may be where life will first be found. Theoretical calculations suggest that there are around 300 million potentially habitable planets in the Milky Way galaxy alone, and several habitable Earth-sized planets within only 30 light-years of Earth, essentially humanity's galactic neighbors. So far, astronomers have discovered over 5,000 exoplanets, including hundreds of potentially habitable ones, using indirect methods that measure how a planet affects its nearby star. These measurements can give astronomers information on the mass and size of an exoplanet, but not much else. To detect life on a distant planet, astrobiologists will study starlight that has interacted with the planet's surface or atmosphere. If the atmosphere or surface was transformed by life, the light might carry a clue called a biosignature. For the first half of its existence, Earth sported an atmosphere without oxygen, even though it hosted simple, single-celled life. Earth's biosignature was very faint during this early era. That changed abruptly 2.4 billion years ago when a new family of algae evolved. The algae used a process of photosynthesis that produces free oxygen that isn't chemically bonded to any other element. From that time on, Earth's oxygen-filled atmosphere has left a strong and easily detectable biosignature on the light that passes through it. When light bounces off the surface of a material or passes through a gas, certain wavelengths of the light are more likely to remain trapped in the gas or material surface than others. This selective trapping of wavelengths of light is why objects are different colors. Leaves are green because chlorophyll is particularly good at absorbing light in the red and blue wavelengths. As light hits a leaf, the red and blue wavelengths are absorbed, leaving mostly green light to bounce back into your eyes. The pattern of missing light is determined by the specific composition of the material the light interacts with. Because of this, astronomers can learn something about the composition of an exoplanet's atmosphere or surface by, in essence, measuring the specific color of light that comes from a planet. This method can be used to recognize the presence of certain atmospheric gases that are associated with life, such as oxygen or methane, because these gases leave very specific signatures in light. It could also be used to detect peculiar colors on the surface of a planet. On Earth, for example, the chlorophyll and other pigments plants and algae use for photosynthesis capture specific wavelengths of light. These pigments produce characteristic colors that can be detected by using a sensitive infrared camera. If you were to see this color reflecting off the surface of a distant planet, it would potentially signify the presence of chlorophyll. It takes an incredibly powerful telescope to detect these subtle changes to the light coming from a potentially habitable exoplanet. For now, the only telescope capable of such a feat is the new James Webb Space Telescope. As it began science operations in July 2022, James Webb took a reading of the spectrum of the gas giant exoplanet WASP 96b. The spectrum showed the presence of water and clouds, but a planet as large and hot as WASP 96b is unlikely to host life. However, this early data shows that James Webb is capable of detecting faint chemical signatures in the light coming from exoplanets. In the coming months, Webb is set to turn its mirrors towards TRAPPIST-1e, a potentially habitable Earth-sized planet a mere 39 light-years from Earth. Webb can look for biosignatures by studying planets as they pass in front of their host stars and capturing starlight that filters through the planet's atmosphere. But Webb was not designed to search for life, so the telescope is only able to scrutinize a few of the nearest potentially habitable worlds. It also can only detect changes to the atmospheric levels of carbon dioxide, methane, and water vapor. While certain combinations of these gases may suggest life, Webb is not able to detect the presence of unbonded oxygen, which is the strongest signal for life. Leading concepts for future, even more powerful space telescopes include plans to block the bright light of a planet's host star to reveal starlight reflected from the planet. This idea is similar to using your hand to block sunlight to better see something in the distance. Future space telescopes could use small internal masks or large external umbrella-like spacecraft to do this. Once the starlight's blocked, it becomes much easier to study light bouncing off a planet. There are also 3 enormous ground-based telescopes currently under construction that will be able to search for biosignatures: the Giant Magellan Telescope, the 30-meter telescope, and the European Extremely Large Telescope. Each is far more powerful than existing telescopes on Earth, and despite the handicap of Earth's atmosphere distorting starlight, these telescopes might be able to probe the atmospheres of the closest worlds for oxygen. Even using the most powerful telescopes of the coming decades, astrobiologists will only be able to detect strong biosignatures produced by worlds that have been completely transformed by life. Unfortunately, most gases released by terrestrial life can also be produced by non-biological processes. Cows and volcanoes both release methane. Photosynthesis produces oxygen, but sunlight does too, when it splits water molecules into oxygen and hydrogen. There's a good chance that astronomers will detect some false positives when looking for distant life. To help rule out false positives, astronomers will need to understand a planet of interest well enough to understand whether its geologic or atmospheric processes could mimic a biosignature. The next generation of exoplanet studies has the potential to pass the bar of the extraordinary evidence needed to prove the existence of life. The first data released from the James Webb Space Telescope gives us a sense of the exciting progress that's coming soon. If you're interested in the future of astronomy, please consider taking a look at this video, which discusses the Louvois mission, which is expected to be the successor to the James Webb Space Telescope. Do you think WASP-96b is home to alien life? Please share your thoughts in the comments section below.